Hello, everyone. Thanks for joining us today. Um, Welcome to our first open training session. My name is Alexey Firsch. I'm security engineer at VirusTotal. Before joining the company this year, I've been an APT researcher at Global Research Analysis team at Kaspersky. So that's why I tried to make this content like 100% practical. Put lots of in the wild examples from my personal experience. So it will be sort of angle that security professionals can leverage VirusTotal features in their day-to-day job. And I hope you will enjoy it. Please do not hesitate to put your questions, comments, emojis, and we will try to catch some time at the end of the session to answer it. So this training is mainly about VTI, the main service to perform a quick IOCs lookups, as well as make complicated queries to find the specific sample with hundreds of different conditions that you're interested in. But I want to start with a quick demo to play around with VirusTotal. I believe this one is a perfect example of how useful VT intelligence could be. So let's try to gather some intelligence on the zero-day case of Fellaini exploit. So for those who didn't know, there was a zero-day flaw disclosed on Twitter by Information Security Research Group from Japan. So the point is it was found by in the wild sample uploaded to VirusTotal from Belarus, which means that the vulnerability was actively exploited at that moment. And I'm not going to describe the flow itself in details, but in order to proceed with our VTI research, you have to understand the basics of this exploit. So in a nutshell, it is related to Microsoft Support Diagnostic Tool, or MSDT, which is basically allows support guys remotely solve your technical issues. And there was a bug in MSDT that can enable remote code execution when MSDT is called using the URL protocol from other applications like Microsoft Word, for example. So combining this MSDT RCE with the remote template feature in Microsoft Word, we can specify the link to such template that contains like common to MSDT with some PowerShell script, for example. So it sounds a bit complicated, but in fact, it's quite simple. We have the this initial sample that was found in VirusTotal. So let's check it out and see how it works. So probably the first thing that I'm trying to check when I'm dealing with the documents is the content tab. To take a quick look at preview, and it's empty. So no interesting information here. Then it would be interesting to check relations. There are like lots of URLs, bundled files, and what immediately attract our attention is this contacted URLs, because contacted URLs basically means some interaction with the remote host, CNC server allegedly. And in that case, we can see the URL that possibly points to a remote template. Yeah, that looks pretty suspicious. The document, the Office document, reaching out to HTML hosted remotely. So let's try to locate where this URL actually came from. So as I already mentioned, the doc file is kind of archived, so it contains lots of XMLs inside. And you can see the first one, which is like highlighted by a number of detections. The XML that contain different relationships. So you can see that there are a bunch of relationships, but one of them looks like our URL. And you can also see that it's try kind of mimic to openxmlformats.org, but in fact it's xmlformats.com. So we catch the place where this URL came from. Now let's try to pivot on this URL. So instead of having this file object, we are now pivoting to the URL object. And for URL object, we have lots of useful information in details as well, like HTTP headers. They are also pivotable, but in our case, it's not super interesting. But what is interesting is the body response. So we can actually grab the file that was downloaded from this URL. And yeah, going to check for content, we can see that something weird is happening here. So for example, here we have this msdt command, and then there is invoke expression and base64 encoded something. So we can grab it, trying to decode it, and yeah, verify that it actually contains some PowerShell encoded payload. So basically this is it. We just follow the entire exploitation chain using only VirusTotal from the initial document, malformed document, to the encoded PowerShell payload. Now the second question is how we can find more of such samples. So in this case, I would say that the main challenge would be not finding additional samples, but filtering all the proof of concepts, because we're receiving lots of such samples from researchers, and script kiddies after exploit was going to public. So let's get back to our initial document. Yeah, and in the detection tab, probably the first thing that you're going to check is detections. And you can see here that we have 2 catches by 2 Yarrow rules. We can check the rule, we can check the quality of this rule. We can see that it's directly related to the Felina exploit. This is not some random detect. And we can also explore all the files in VirusTotal detected by this Yarrow rule. And yeah, as I said, lots of proof of concepts here. Like you can see the name sample or leaked or Felina. So the main challenge here, the main task, is to filter in all the irrelevant results. And for that purpose, I would say we have different approaches. Like for example, we can just take a look only on these samples that was uploaded to VirusTotal before the exploit became public. So we have file submitted, a keyword, and what was the date? May 27. And you see how 2K samples became 40 samples. And it's completely doable to analyze them manually. Yeah. But using this file submission modifier, we always at risk to miss something interesting, but submitted after this date. So as another approach, we have we can just filter them out by name. Like we can use not keyword with the name. Say we are not interested in files named with the name Felina. Then we can just extend this like this, sample. Diagnostic. And this way, step by step, we can filter out irrelevant results. As another approach, we can use, it's also based on dates. We can use creation date. So creation date, well, it speaks for itself. So we can again check only the files created before. And we can see much more because, yeah, some of them were created before and then submitted to VirusTotal after exploit became public. As a completely different approach of searching for additional sample, we can use pivoting on lots of different information here. So, for example, we can use the metadata. We have EXIF tool output here. We have document properties, which is pretty much the same. So important thing here is this keys2, which is allegedly the author of this document. And we might want to clarify the search by specifying the type of the files that we're looking for. Document. Yeah, because metadata is not only about the documents. So yeah, the fun thing with this keys2, after exploit became public, the bad guys, they just read the news, like there is an unpatched vulnerability in the wild. So they took this initial doc, catched by Japan guys. They modified, like they put, you probably remember that it was empty, so they put their own luring content, they put their own CNC address, and they started to distribute. So you can try to search for such samples. They, I remember there are like number of them contained this keys2 in metadata, but at the same time, they have a different timestamps, different than the initial document, which point us to possible modification of this file. It's also worth to check the remote template itself. I found it very, very useful and relevant to check, to catch more Felina samples. Let's navigate to the remote template. Yeah, so first of all, we have a feature that we call VT-grab. So you can actually build your search based on the file content. So in this case, we might want to look for something like this. You can click actually on anything on the content tab, and it transforms your string into hexadecimal. But you can just put it here. Quotes are escaped. So yeah, works good to me. And then you can remove this. Yeah, and we got some samples. Probably they are not all of them related to Felina, but they are something to do with this MSDT code execution, definitely. Another cool thing about the remote template is unusual, I would say, combination of these file types and magic headers. So you can see we have a PowerShell with the HTML magic number, and we can actually combine them to build the query like this. Still, there are a couple of, well, probably some of them are false positives. So we can clarify our search. Like, let's say we're interested only in the ones with a known distribution host in the wild URL. And yeah, you can see that the false positives are gone. Definitely some malicious stuff, but not related to Falina. And yeah, this is definitely related. This is pretty much it on the demo. So still, we do know that most of VT users are using search to perform like quick lookups just to grab the hashes or IP addresses. And that's okay. We just need to remember how powerful VTI could be, providing us with the ability to create such advanced queries. And just a couple of quick examples here. For example, we are looking for a specific document with some braid in its name to check for any luring attempts. And the different one, we're looking for URLs that contains some brand name in the title. And you can see that there is lots of fraudulent sites mimicking JP Morgan. So yeah, the search is also could be used to check strings for popularity before adding them to detecting signatures, like Yara, for example. And yeah, when we say we are limited in capabilities, it's literally unlimited within our technical possibilities, because you can always reach out to us and say, hey, we need a special search modifier for this, and yeah, we will take a look how we can help. Because all the data is already here, we're just looking for the ways to fetch them. So for example, during this year, the company, I already pinged developer guys for a couple of times, like, let's make this keyword to easify Android app search, or let's make this keyword to filter collection entities. So that's a cool way to interact with the VirusTotal. So just a small piece of theoretical knowledge here. So basically, you can put in a query whatever you want. So it could be just a weird comment that you found in a malware sample, or suspicious domain name, or just a super malware. At the end of the day, this is what we are looking for. Yeah, but the thing is that we cannot provide all types of possible outputs in the same table view. So you can imagine that would such a mess. Domains, files, IP addresses in the same table. That's why VT is trying to recognize what kind of output you want to get. So you can actually control this with a special keyword, entity keyword, to directly specify the type of output that you are interested in. And in our super malware case, VT doesn't recognize domain or IP, so it is used the entity file by default, just hidden from us. And of course, this is a super simple query, and we might want to improve it somehow. For example, like we want to take a look at the super malware that have embedded URLs, and we have malware with embedded URLs. So for every entity, we have a number of special keywords and they are well documented. There are tons of them, so you can check them manually and apply to your specific case. So yeah, and we have a number of such entities actually. We have IP, domain, and we can actually request it for a collection entity. And for each of this entity, we have a bunch of special keywords that you can actually explore in our documentation. So great. Now I want to explore like group of file search modifiers related to execution behavior. Let's say we have a couple of malware IOCs from a third-party report with detailed malware analysis, and we just want to get more context of it. So for that purpose, we can use our behavior search modifiers, which are related to the sandbox reports. Yeah, they appear every time you pivot on something in behavior tab. So as an example, we have this sample from the Blue North group, which is a financially motivated group linked to Lazarus. And yeah, let's get this sample and navigate to behavior. And let's start with the network communication. So I would say that in most of the cases, well, you can observe lots of things here, like starting from DNS lookups of the CNC server and HTTP headers, or you can just you can put the, in such query, you can put the random pickup content. So we storing all this data under the same umbrella, but I would say in a 90% of the cases, you just want to use your CNC address to get a couple of more samples interacting with the same host. Yeah, so for file system operations, I would say it's pretty much the same stuff. So you can just click on any entity here to make your VT query. So we are using the full text search, so no wildcards are allowed, but instead of this, you can just strip irrelevant path to keep only the only unique one, like this. Yeah, and we get 100 of suspicious PowerShells. Well, not PowerShells, but the files that probably execute PowerShells. Yeah, and you can actually build a complicated query based on behavior. For example, we can mix the behavior processes, which is actually available in the sandbox report right here, I believe. Yeah, so we can mix it up with the network keyword to get the files, let's say, that interact somehow with tiny URL, and at the same time that they're doing something with PowerShell. You can see that almost all of them are detected by AVs. So, well, most of them would likely, high likely are malicious, but perhaps most of them are not related to Blue North. But that's what is all about, trying to different generic approaches. Some of them could lead you to different samples from the same campaign. Some of them could help you to uncover another actor's activity, and some of them represent the typical malware pattern. And a bonus track here, a quick note that you can actually explore hidden cases with VirusTotal. And why are they hidden? Well, we obviously cannot visualize all the sandbox logs in our user interface on the website, obviously. But what we can do is to search among all of this data. And that's actually what VirusTotal doing when you put a query. So this is a quite recent case. Tech guys reached out to me and asked if we can search for specific user agent string in VirusTotal, and I thought that we cannot because we don't have a special keyword for this. So I started to dig into this. Maybe we should make a new one, and turn it out that we can actually leverage behavior network modifier to look for the user agent string inside all of the network logs. So this one is on Bumblebee malware. And you can actually see that there is no Bumblebee in the behavior tab. Yeah. No Bumblebee mentions, but yeah, it's hidden from us, so we can still use it by query. This is sort of VirusTotal magic. Here we have a story on a Calibri loader from Malwarebytes. And we can quickly take a look at the report. And it contains only 3 hashes: Calibri loader and Mars stealer, if I'm not mistaken. So yeah, let's try to pivot on this one of the samples. Again, let's check the network communications. And you can see that there is a lot of HTTP requests. So yeah, we can click on, well, I think this one would be the most relevant. It's in much, so let's try to improve our query by removing the CNC address. So now we are trying to get all these similar samples that using the same CNC protocol, but on a different hosts. So yeah, and you can see that there are more of them. This one is computer protect as well. And this one is secure tunnel. So we just found the sample that that is using the same CNC protocol, but with the different CNC server. Next one is a quite rare case. I would say it's infamous FinSpy, but for macOS. And we got this installer from Amnesty International. So we do have a sandbox for Mac. So we can check for the details, but it's not super cool. Yeah, it's saying much. So this is probably because we are pivoting on the one single binary from the package. So we might want to pivot a little bit on parent. And yeah, this Mac disk image is actually what we are looking for. And check this sandbox report here. You can see that we have much more details. So I already knew where to look because we were conducting a big research with detailed reverse engineering. So in a nutshell, FinSpy across all of his desktop versions, like Mac, Linux, or old version of Windows implant, it's storing the config in such files like 7fc .dat or atc.dat, and combining just these files together, we can build a query to get all the files that somehow deploy these files during the sandbox execution. And you can see that we have actually a PE files here. So we just jumped from a Mac implant to the Windows implant, just using the behavior files search modifier. So this is the big one. Here I tried to collect queries for different cases on the different platforms, so you guys can see how flexible the search modifiers could be. And in this first case, so we are looking for the signed files that's supposed to be signed with a Microsoft signature, but at the same time they're detected by a number of AVs, so kind of suspicious. The problem that I found here is that this signature modifier is based on complete output of SigCheck tool from MS internals. And apart from the certificate details, this tool also provides us with a file version information, which is not validated and not related to certificate signature. So you should always keep that in mind, because bad guys can put whatever they want in a file version info, such as Microsoft Corporation. But the file could be not signed at all, or signed with some kind of VeriSign certificate, which is not trusted. So we can just remove, to demonstrate this, we can remove signed tag at all. And you can see that we have millions of files with the Microsoft Corporation in signature, but in fact it's not signature. Let's try like this, not tag. And we have millions of unsigned files, but with Microsoft Corporation in file version information. The second one is super cool. This is actually a functionality that you usually expect from internet scanning services like RiskIQ or Census. So we can search for URLs with a specific cookie name or cookie value, and this simple query is related to MageCard, online skimming actor. We can even search for specific HTML metadata entities. And here I have a cool story how I tracked the origami elephant APT for a long time. So the thing is that these guys distributed the Android implants in a super targeted way by sending a link with a malware directly to the victim. And perhaps some of you may know that you can actually make a custom link preview in WhatsApp by specifying a couple of parameters in HTML meta section. And yeah, there is an open graph from Facebook that allows you to customize this preview. And for example, you can link this page to the Facebook app, so you can track click statistic, for example, and some kind of site data. And apart from making a luring URL preview, these guys, they also track the click statistic by specifying this their Facebook app ID, and it was the same across all of the spreading hosts. So that was a kind of breakthrough moment. I just came to all available internet scanning services and made a rule based on this Facebook app ID. yeah, that's how I found all the current hosts, as well as track for a long time for newly deployed ones. And I don't remember the exact values of this app ID, but yeah, I do remember that they use this Android share title. Like, this URL is definitely related to Origami Elephant. But to use metadata search, we might want to have something like OG app ID, something like this. Exactly. So yeah, this is actually a Facebook app ID, and you can just leverage it to track all the URLs linked to this Facebook app. So yeah, from my personal experience, when you're dealing with APT cases, the most beautiful search tricks are usually quite super short. You just need to make careful reverse engineering. Like when you have tons of different conditions, it's more like a machine detection or kind of generic approach. And the main goal with the sophisticated cases is to find such gems that you can use in your search. So the next one is related to AndroGuard. AndroGuard is Android security framework. It's completely static, so static analyzer. It provides us with tons of decompiled data, like code strings, resources, certificates, manifest entities, and such, etc., etc. So the thing is that we are storing everything on the same umbrella under AndroGuard tag, and there are pros and cons of this concept. Sometimes we need to search for manifest entity only, and we don't want to get the output of, well, based on some code strings, for example. And the next one is from one of my colleagues. This is a kind of really smart workaround to split the different types of the output within the same AndroGuard tag. So you can see we are looking for some Android applications with the specific icon-d hash, and you can get this hash by just by clicking on the icon in VirusTotal. So yeah, we're looking for APK with some specific icon which is related to BBVA Bank, and not AndroGuard something and not AndroGuard something. And this something is actually related to the official signature of BBVA. So in fact, we're looking for some fake apps that try to mimic BBVA, but at the same time, they are not signed with the official signature. And there are a couple of zero positives here, but most likely, yeah, it's because they are not signed at all. And you can see that there is a bunch of samples, which is definitely related to a malware that trying to mimic BBVA. So that's why I dreamed about the next feature for years. And finally, when I joined the company, I asked guys to implement this Android package search. For cases with the FinSpy or brand protection, as we just saw, it's incredibly useful. For example, FinSpy, and other more common underground malware. They were generated by sort of desktop builders, and in case with FinSpy, they have a default package name, and if you didn't change this value during the build generation, it will be the same every time. So you can just put this package name here and got this FinSpy samples, lazy samples. Another example, well, all the package names of installed applications on Android device are unique. So there could be only one app with a specific package name. And one of the simplest techniques used by Android Bunker is replacement of original banking app with a malicious one. So that's how we can search for such fake apps. Yeah, just wanted to note that this one works only for newly processed files since March this year, I believe. So next one is quite interesting. Again, we have two queries. One of them we're looking for from Mac suspicious files distributed somewhere in the wild with a known host from the known hosts. And the other one, we are looking for files distributed from Discord network. And again, it would be cool if we can construct a query not based on number of AV positives. So we can just combine them together, remove positive. Yeah, and here we're looking for files, for Mac files distributed from Discord. And yeah, you can see that there are legitimate files. There are some suspicious files as well. For emails, that's pretty straightforward. Probably you already knew it. So we are looking for emails with a attachment that's supposed to contains an exploit. We have plenty of such files, so we probably want to get only the most recent ones, like this month, and only 200. Cool. And yeah, this is only the tip of the iceberg. So I just wanted to show you guys how flexible these search modifiers could be. And basically, you can employ them all on almost every hunting-related task. As a part of today's talk, we'll have this God mode level of VTI experience. How can you automate the VTI search to track, like you can track everything, but in our case, we will track APTs. So all the queries that I covered today could be automated with our API. And to demonstrate how we can leverage this, I made the APT dashboard to track actor footsteps in VT datasets. Unfortunately, right now it's in the form of a proof of concept, like only Jupyter Notebook. So it doesn't have a fancy UI. I'm not going to demonstrate the entire dashboard, just a couple of screenshots, and we're going to talk about basic concepts. Hopefully next time we will be ready for smooth and dedicated presentation. Yeah, so basically you can select the name of the group, then click the magic button and gets tons of data related to this actor. Here we have a timeline, for example, timeline of samples appearance, and a breakdown by file types. Apart from charts, it's also provide us with lots of recent IOCs. Well, I use multiple ways to fetch this data. And on the screenshot, you can see the files related to the actor according to AV vendor verdicts. So for sure, you can build a more complicated approach, more complicated logic, even on this one, like using your own list of trusted AVs only, or put some threshold on a number of different verdicts related to the group. Now let's take a closer look under the hood. So the dashboard is based on our API only. There are no tricks or requests to hidden VirusTotal backend. I literally put myself in a VirusTotal customer environment, and I used our VTI Python client instead of raw API. So the cool thing with the Python client, you can retrieve any VirusTotal object and operate it how you operate the regular Python objects. So basically, API was designed to fulfill all the website interface available tasks, and sometimes even more. So you can for sure perform VTI searches, and you can even manage your rule sets, if I'm not mistaken. And of course, we have detailed manuals for both API and Python client library as well. You can just Google for it, or you can just navigate to our site. So here you can compare. On the left side is an API query from a raw Python with a request model, and on the right side, same request but using our Python client. And what we're doing here is trying to retrieve the comments containing the sophisy tag. The most part of the dashboard, I would say like 95%, is based on a regular search queries. For example, here we're trying to retrieve a sophisy collections, and you can see on the right side the Python implementation of this query. So our search is based on name and collection tag, and yeah, these the attributes of the collection that can refer to some APT. And as you can see, we are free to use as much as aliases as we want. This is exactly what I did in a dashboard, just put like dozens of them in one single query. The next one is a very special search. I would say that one of these 1% use cases. And this is the graphs listing query. So here we're using a different endpoint, which is URLs, which is graphs. And this is not the VTI query exactly. This is the query for searching graphs specifically. And as you can see, it has a different parameters if you can compare it with the VTI. Let me close the other tabs. So you can see we have a bunch of graphs. And for example, this one I titled Untitled. It doesn't contain the sophisy in its name, but I think it just yeah. So we have nodes with the label it with sophisy tag. That's why we see this graph in the results. Here we have pretty much the same queries that I use in the dashboard. So you can gather the same data with these queries. Imagine you have a wrapper from a third party that contains like 0 IOCs, like this one from NSCS. It's on well-masked malware used by APT29 to target vaccine development. Super sensitive case, lack of ASCs, everybody's looking for samples. And you can carefully check the report, and you can see that there ain't much information, but there is this well-masked mention and well-mail. So we can leverage even this malware name in our search. Just put it in with engines keyword to get all the samples detected by verdict that contains well-masked. If you have like a trusted AV vendors list, you can search for specific vendor verdict. Like here we're looking only for files detected as well-masked by ESET or Kaspersky. With the next one, we are looking for all domains that has a comment with the specific content, like APT29, Kozebir, blah blah blah. We can leverage it for domains and for any other entities that we face it. Like I found it is most relevant to files because we have this Tor scanner that sometimes put the APT name in the comment. So you can just use this approach to get the relevant files to the APT group. The next hint is to use our crowdsourced rules. For Yara, IDS, and Sigma, you can just specify part of the rule name. In our case, this is an APT group, and VT will provide us with all the files detected by these rules. And last but not least, we can list collections based on its name and tag. We can filter it by dates. And of course, we can leverage it to catch the recent collections for specific APTs. What's important and super cool feature here is that we can build our search based on specific collection. So for example, here we just need the collection ID, which could be extracted here. Let's get another one with the more samples like this. So this one is a collection ID. You can put it in a query, and then let's say we're interested only in a recent files submitted to VirusTotal recently. Well, not that recently. And only, let's say, DLL. Yeah. So with all these queries in mind, you are now ready to make an even better dashboard. This is pretty much it from my side. Thank you very much. Just looking for questions. Wow. Do you know when this APT tracking dashboard will become available for us? Hopefully the first Q1 of the next year. I hope so. Can we get the presentation? Yeah, we are thinking about it, and hopefully we will find the way to share the slides, because yeah, it contains lots of queries and links to documentation. The recording will be shared later on Bright Talk, I believe. A very cool jumping from Mac to Windows. Yeah, I found it super cool. That's the thing with these behavior searches. So we are not stricted into specific platform. Do you have a session talk like this, but where we interact with the API more? That's a good one. We can think about it. If you are really interested in, we can make a session. Can you point out allocation for all the most useful queries? That's another thing that we are working on right now. Hopefully we will have a so-called VirusTotal cheat sheet pretty soon, and we will release it publicly. What was the P5 plus term? Yeah, maybe I miss it. So P and a number here refers to positive detections. So here we are looking for files detected by 5 different antivirus vendors or more. So we can put just 5 to look for the files with the exact 5 detections, or we can put dash to get the files detected by 5 AV vendors or even less. These features are available in the free version of VT. Some of them are available, some of them not, unfortunately. Could you share the URL and searches performed? Well, I see the interest in sharing the slides and the queries, so I think we will try to find a way to share the slides. What does in the while URL define? So I believe you are referring to this one, in the while URL. And it's about have keyword. So we are looking for files that have something. And here we are, well, we can search in documentation. And you can see that there are like intelligence, file search modifiers. And yeah, you can see that there's a lot of options for have. So you can specify have in the while URLs, have packers, have parents, have pickup, and whatever. So we are looking for files that have in the while URL, which means that we are looking for file with a hosting information. So we definitely know that this file was downloaded from this URL. What is your keyboard? Super nice sound. Yeah, thank you. It's from Drop. Um, YAR rules analysis in VT are available for everybody. I think so. Well, we are out of times. Well, out of time, guys. Thank you very much for joining us. Lots of questions. Sorry, I can't answer them all. But thanks for the feedback. Thanks for joining us today. Thank you.